To explain this one more time, a little bit clearer for everybody. You could simplify the square root of 25, and that's going to be 5. So you really have a 3 plus or minus 5 over 4. And that's really saying two things. 3 plus 5 over 4, and also 3 minus 5 over 4. So on top, 3 plus 5 is 8. 8 over 4 is the nice, beautiful answer 2. And on the bottom, 3 minus 5, that's negative 2 over 4. That is a fraction, but since you could reduce it, you might as well reduce it to negative half. So both answers there would be 2 and negative half. Let's move on to this next one. And what I want to do is simplify the square root of 32 right here on the side. The square root of 32 is really 16 times 2. You want to go for the highest perfect square number, and that ends up being 4 square root of 2. So I'm going to replace the square root of 32 with 4 square root of 2. So I'm going to have now 4 plus or minus 4 square root of 2 over 4. Now there's many ways of finishing this question or this problem off. One way is to recognize, hey, I have 3 terms, 1, 2, 3, and they all have the multiple of 4 in it. So it's kind of like reducing, right? You could cancel all 4s, reduce by 4, reduce by 4, reduce by 4. Or another option would be to actually split the denominator to each term, all right? So here we go. Let me show you that. 4 over 4 plus or minus 4 square root of 2 over 4. And then when you ask yourself, 4 over 4 cancels out, it's 1. The plus minus is still there. And the 4 over 4 also cancels out, but you have a square root of 2 left over. So it doesn't really matter which way you get to this final answer, as long as you get to the final answer. So the other way was to actually cancel 4, 4, 4. It all reduces. It becomes a 1, a 1, and a 1. And you'd get to this final answer anyway. So it's up to you if you want to split the denominator or just reduce all 3 terms by whatever you could reduce by. Let's move on to number 3. So on this one, I'm going to reduce I'm going to simplify the square root of 8 on the side. Square root of 8 breaks down to 4 times 2, and when you split 4 and 2, you're going to get 2 square root of 2. So I'm going to replace the square root of 8 with 2 square root of 2. I'm going to have 8 plus or minus 2 square root of 2, and it's going to be over negative 4. Are you with me? Yes. Okay. What I'm going to do now is, well, you could reduce everything by what? 2. By 2. Right? You could reduce everything by 2, and if you don't see it that clearly, it might be a good idea to actually show that you separate the denominator each term. So it might be a good idea to do this. 8 over negative 4 plus or minus 2 square root of 2 over negative 4. Okay, now it's a little more interesting because 8 over negative 4, what's 8 divided by negative 4? Negative 2. It's negative 2. So I really have negative 2 plus or minus. And how about that other fraction? Right here you have, it's kind of like saying 2x over negative 4. It's a negative 1/2, right? Now, don't we already have a plus and a minus right here? So it really doesn't matter if your minus is down here or if it's up here or if it's not even there, right? Because you're still going to add and subtract it anyway. So what you could do is just scratch out your sign on that last one and actually just reduce 2 over 4 and get 1 square root of 2 over 2. So your final answer should be this. Negative 2 plus or minus square root of 2 over 2. If you wanted to put a 1 right here, that's fine. You could say negative 2 plus or minus 1 square root of 2 over 2. And another acceptable answer, instead of going from here to here, you could also just reduce everything by 2 and write down 4 plus or minus square root of 2 over negative 2. But see, that's still not as nice as that guy over there, especially because you still have a minus in the denominator. So I guess the best route is to split your denominator into each term, the way we did right here, and then go to your final answer right there. Now, you're probably wondering why I'm circling everything. I have no idea. Just circling. Okay, let's move on. This next one, again, we want to simplify rewrite the square root of 12. Square root of 12 could be rewritten as 4 times 3, and when you split that root, you'll get 2 square root of 3. So I want to have negative 6 plus minus 2 square root of 3 over 4. And yeah, you could reduce everything by 2, or you could split the denominator to each one and get negative 6 over 4 plus minus 2 over 4, but the top part does have a square root of 3 on it. So your final answer will be negative 3 halves plus or minus 1 square root of 3 over 2. In this case, you could just go from here and say, okay, all of these have a multiple of 2 in it. Let me reduce by 2, reduce by 2, and reduce by 2. And this would be an equally acceptable answer, negative 3 plus or minus square root of 3 over 2. As a matter of fact, this one actually looks better than this one over here that's circled in red. But are we understanding this on how to simplify the last step of the quadratic formula? Yes. I hope so. Right here on number 5, it's a little different because we actually get complex answers. What is the square root of negative I? 3i. 3i. Only one person knows. Hopefully everybody does. The square root of negative I is, or negative 9 is 3i. So what I'm going to do is simply replace the square root of negative 9 with 3i. So I have a 1 plus minus 3i over 3. And is there anything else that I could do? Could I cancel out these 3's? No, right? You can't cancel out those 3's. And if you're wondering why not, right? 3 divided by 3 is 1. Let's go to let me go get a little bit off this question. Let me go to something really easy. Kind of like 3 plus 2 divided by 2, right? 3 plus 2 is 5. Is 5 divided by 2, is it 3? No. So that's why you cannot cancel. You cannot cancel if you have a plus or a minus, all right? You just can't do it. So I hope that kind of clears it up. Whenever you have a plus or a minus, you can't just cancel things out. So that 3i on top and the 3 on the bottom, you cannot cancel those out. So what I could do and what I have to do, I cannot leave my answer like this because we can't leave complex numbers together like that. You want to split the denominator. So you're going to have 1 over 3 plus or minus 3 over 3i. And of course your final answer would be 1/3 plus or minus I. Shugare? Number 6. Let's simplify the square root of negative 75 on the side right here. First of all, that negative becomes an I. And then you have 75, no more negative. And 75 breaks down to 25 times 3 with an I on the outside, and you could split the root to the 25 and to the 3. So you really have I times 5 times the square root of 3. So whenever you are dealing with simplifying, like the square root of negative 75, the best order to put it in would be 5i square root of 3. That's when you have a monomial term like that. But we'll see right now when we actually write the complex number how we could rearrange things. But anyways, right now, all I've done is change the square root of negative 75 to become that. So I'm going to rewrite this, negative 10 plus or minus, and instead of square root of negative 75, I'm going to put 5i square root of 3. And it's over 15. Now at this point, I could reduce all 3 terms by 5, or I could split the denominator to each. Either way is good. I like to split the denominator to each, especially because we have I, which means that you need it to be a binomial. You need it to be totally separate, the real part first, the imaginary part second. So I'm going to separate them. You have negative 10 over 15 plus or minus 5I squared root of 3 over 15. Now, when you do write it like this as a complex number, you probably want to move this I to the outside part of the fraction. But for now, I'm just going to leave it like that, and I'm going to reduce everything possible. So, the 10 over negative 15, if you reduce by 5, you're going to end up with a negative 2 over a 3. That's an ugly 3. So I really have negative 2/3 plus or minus, and over here the 5 and the 15 reduced by 5, you get a 1 on top and a 3 on the bottom. So you'll get an I square root of 3 over 3. So this is a good answer. It's acceptable. I'll give you credit for it. However, the best answer is to take the I and put it out here behind the second fraction. So the best answer is negative 2/3 plus or minus square root of 3 over 3 with the I at the end. Because that looks like a true complex number. Real part first, imaginary part second. Moving on to that last one, number 7, we want to simplify. So I always try to simplify the radical first. Could we simplify the square root of 13? No. Oh, that's not good. If I split the 12 to the 5 and to the square root of 13, am I going to be able to reduce anything? No. So there is no purpose in splitting it. Do I have a negative inside the root? No, so I don't have an I either. So when I say simplify it, it's already simplified. In other words, if you do the quadratic formula and you do the discriminant, which is the inside value of the root, and you get 13 and you have these numbers on the outside, there's nothing else to do. That would be your final answer. You wouldn't mess with it. And I hope that helps everybody. That's going to be on Edmodo.